What is georeferencing? It is a process that aligns a digital image with its real-world location. Georeferencing is commonly used with aerial photographs and with maps. We will focus on maps, but the same process can be applied to other kinds of images. First, you're wondering, what is georeferencing good for? One of the best things it does is help you visualize change over time. Here, our first image shows a 1797 map by a man named Carleton, layered on top of a 2001 orthophoto, which is a geographically referenced aerial photo from Massachusetts GIS office. This is a striking example of how bringing an historical map into its true location on the ground can reveal wonderful things about how places change. The second thing georeferencing is good for is comparing maps from different times at different scales. This example comes from David Rumsey, the famous map collector and host of the David Rumsey website. He had two maps of New York City from the 19th century at very different scales. In the left-hand panel, a map from 1836 at a scale of 1 to 13,840, and on the right, a map from 1852 at a scale of 1 to 3,450. How do you bring these two maps together in order to see change in a particular New York neighborhood? Here, the neighborhood of Tompkins Square, which was developed between these two dates. Well, by georeferencing them both to the same reference data, it's possible to overlay these remarkable maps and see the birth of a neighborhood. The third thing georeferencing is good for is enabling you to extract historical data from one or more historical maps of the same area so that you can bring that data together in GIS. I have two examples here of urban areas. On the left, the street network in Gettysburg, Pennsylvania, which has been digitized and then can be extracted from an 1874 topographic map made after the battle. On the right, Portland, Maine, as shown on an 1898 U.S. Geological Survey topographic map. Here, the urbanized area has been digitized as polygons or areas that can be extracted and combined with other data in GIS. There are other, as we say, cool things that you can do with georectified historical maps. Here's another example from David Rumsey. He and his GIS team more than a decade ago georectified U.S. Coast Survey maps of the San Francisco Bay Area. This one is from 1926, and draped them over digital elevation models, or DEMs, of the bay. Here they've used vertical exaggeration to bring out the chasm in the bathymetry underneath the Golden Gate Bridge to help highlight what a dramatic engineering achievement that was. Now here they've used bathymetry for the DEM. You could also bring in a DEM of the land surface and show the hills with this historical map draped over them. And my last example is that you can use an historical base map in your final display of results. This is what my research team and I did in the Gettysburg project. We extracted elevation contours from the 1874 map of the Gettysburg battlefield that you see here in the background. We used those contours to run what's called viewshed analysis to estimate what Civil War commanders could and could not see from certain points on the battlefield. Here we have our estimate of what Lee could have seen and what he couldn't have seen from the top of the Lutheran Seminary, the invisible areas in indigo, the visible areas where the map shows through. Using historical maps behind GIS data gives your presentations a more historical feel, shows your valuable map sources as part of your research, and can add a kind of authenticity to your presentation. I have 4 tips for georeferencing, and all of them have to do with how and where you place control points. As you'll see in the next module, control points are essential for georeferencing. The first tip: always go from the historical image to the reference layer. Here, going from that 1797 Carleton map of Boston to the 2001 MassGIS Digital Orthophoto. And I'd like to acknowledge here my colleague Patrick Florence, who created this image when he was at Harvard. He's now at Tufts University. Tip number 2, distribute the control points across the image as much as possible. You'll see that Patrick's 3 control points cover pretty much the extent of his map. This tends to produce the least distortion and to get the best representation of actual location on the historic map. Tip number 3, look for landscape features that do not change much. Using unchanging landscape features will help you make the strongest, truest links between the historic map and your reference data. Here from the Gettysburg map are 2 kinds of good examples. A field corner or the intersection of 2 streets is less likely to change than some midpoint along a street or in the middle of a field. And the lower highlight of a historical building, if you know that buildings were present at the time of your map and they're shown on the map and they're in the present-day landscape, they provide excellent control points. Administrative boundaries that have not changed, such as township or county lines, can also be good. The worst referencing features generally have to do with water. Rivers, coastlines, even along an ocean coast, tend to change and so are not stable references for control points. And lastly, find good reference data. Finding good quality data sources, such as this street layer and water layer from the Massachusetts GIS office, or data from the U.S. Census Bureau, tends to provide really high quality references for georeferencing.